Right, good day, class. So our discussion for today is about our numerical summary measures or the descriptive statistics atong data. No? So we'll discuss measures of central tendency that includes the mean, median, and mode. And then we'll discuss the measures of dispersion or how dispersed the data are from each other. No? So their variability. We discuss range, variance, and standard deviation. Okay, so the most commonly investigated characteristic of a set of data class is its center, or the point about which the observations tend to cluster. So if you graph our data, for example, sa atong x-axis, these are the observations, different observations. And these, sa y nimo, this is the frequency. Okay, so we see the normal curve kining middle mo ni ang normal, no? This represents a perfectly symmetrical distribution. So it depends on the values of mean, median, and mode. Makita sad nato ang itsura sa atong graph if it is skewed to the left or skewed to the right. So you have here negatively skewed, meaning skewed ka ng slanting siya ang area class. So negatively skewed is when your skewness is nasa imong left side. Okay, so na imong negative side. And that means your mean is somewhere here. And then your median and your mode are both at the right of your mean. Okay? So again, this is the mode, this is the normal curve, symmetrical siya. Kining duha negative and positive skewness na graph nimo are asymmetrical, no? So for positively skewed class, sa positive po nimo nga side, it means sa imong right side ang imong nakaslant ba. Okay, so your mode and median are on the left of your mean value. Okay, so unsa man ni siya ng mga values and how do we get these values from our data? Okay, so I'm sure you're familiar with mean. Okay, the mean or what we call the average. This is the most frequently used measure of our central tendency. So this can be used as a summary measure for both discrete and continuous. Dili siya pwede for nominal and ordinal because you cannot get a mean for this data. Okay. And na siya characteristic class that it is extremely sensitive to the extreme values. So nata example ana later unsa ka drastic ang iyang change sa values iyang mean if we have extreme values. Okay, so how do we calculate the mean? It's very easy. Actually, dili ganita aware no nga gakuha na tag average, but on a day-to-day basis, example for my profession, because I am an instructor, college, I am a teacher, okay, educator. So most of the time I always get the average. For example, average score ninyo sa inyong quizzes, average score ninyo sa inyong exams, or even average grade ninyo sa midterm finals. Okay, and then based on the value, I draw inferences or conclusion, or siguro matanaw na kung sa mga factors affecting ano yung ani ang value sa average sa akong exam sa akong student. Okay, how do we get the average? Of course, we sum all the observations in a set of data and then divide it by the total number of measurements of pila ka buok. Okay, so dapat kabulutan mo read og mga ingani nga notation. No? So this is our mean. Okay, we have here x bar to indicate that we are calculating the mean of the observations ng mga x. Okay, and then that is equal to 1 over n. Okay, mamaya natong i-divide no sa total. The number of observations, okay, multiplied by the summation of your x sub I from 1 to n. Okay, x sub I is the ith observation nimo, values mo ith observation. Okay, so for example, this table 3.1 here, no? This is the forced expiratory volumes in 1 second for 13 adolescents suffering from asthma. So, in something FEV, just to give you an idea, it is a type of test, no, to know the lung function sa isa ka tao, and especially if they're suffering from asthma or any respiratory nga mga disease. So, ang buhatan nila is ipa-inhale ang patient, deep na pagka-inhale, and then after which they force they have this term lagi nga force nga pag-exhale, and then whatever ilang ma-measure na by virtue of their component or equipment kagamit, they can measure the forced expiratory volume kanang air nga iyahang na exhale at 1 second. Okay, so suppose in this table or in this data that we have now, 13 kabuok adolescents. ang gikuha ng FEV. So muna yung mga values, 2.3 liters, 2.15, and so on. Okay, so how do we get the value or value of the mean or the average? Of course, that would be isam na to daan ng mga x sub I. So that means class mo na itong x sub 1, x sub 2, x sub 3, no? Until x sub 13. So x sub 1 here, okay? X sub 2, x sub 3, until x sub 13. You add all of that divided by 13, and that would be your mean. So that is equivalent to 2.95 liters. More than ang mean niya, average na yung value for all the subjects or for all the participants ani nga test. Okay, so ano na siya dito kanina nga, the mean is extremely sensitive to extreme values. For example, we have this data, no? Itong original data. What if in for some reason lang yun, the one administering the test, nasayop siya og input. Instead of 4.02, na input niya is 40.2. Okay? So as compared to your other values, dako kayong 40.2. Now, if you get the mean of this data, no, and then this will become 40.2. What happens to the mean? Okay, it will become 5.73 liters, which is nearly as twice as large as it was before. So, if I were to analyze in a way, no, dili po na to diretso ma-conclude nga sayop siya, pero it could be an error sa imuhang pag-input sa values because the mean actually is, since it is an average value, makaingon sad ka nga ang imong mga values could be just near these values. For example, ang imong first na compute nga mean is 2.95. So tanaw mga values 2.3, 2.15, 3.5, 4.25. So galaro lang gid ana. Ga-revolve ra ana ang values sa imong mean. No? Pero if you have 5.73, you may question, hala nga nang inani ang mean niya when the values are 2, 3, 4. Of course, it's because of this value nga nahimo nimo 40.2. So dako ka siya effect, no? Ang extreme value sensitive ka siya sa imong extreme value. Okay? So again, daghan ka pwede ma-inference based sa imong mean. Pero dili po nato siya masaligan diretso nga nga error siya. Okay, basin mao gid ang iyang value nga nari. Okay? So adto ta sa another measure of central tendency class nga dili kaayo affected by extreme values, which is the median. So this is another measure of central tendency. As I mentioned, hindi ka siya sensitive sa value of each measurement. And this could also be used as a summary measure for ordinal. No? Dili na siya sa discrete o continuous, pero apil ang ordinal. Basta naa kay ranking sa imong observations. And this is defined as the 50th percentile of a set of measurements. Diba, naingon na ko ka itong last meeting that the 50th percentile is a value that will divide your group. Meaning, kana nga value, 50% of the subjects will have lesser than that value and then another 50% will have greater than that value. So, bali na siya sa tunga-tunga. So, this is the median. Okay, so what are you gonna do to get the median? First is you rank the observations from the smallest to largest. Okay, x sub 1, x sub 2, till x sub n. And then if n is odd class, meaning the number of observations is odd, ang median mo is the middle values. For example, you have 5 observations. Okay, 5 lang kabuok. So your median will be x sub n plus 1 over 2. So that is x. 5 plus 1 over 2. So that will be x sub 2. Okay? So mula na ba nag 1, 2, 3, 4, 5. Ang pinakatunga ni mga value is the x sub so si x sub 2, x sub 3. Okay, x sub 3. Ang ikatulo. Okay, so muna pinakatunga ni mga value. That is for when your n is odd. But if it is an even class, for example, 6 ka mo, di na ka pwede nga 3. X sub 3 ang imuhang median. The median will be the average of the two middlemost values. Ang average, kanima sila ang middlemost values, di ba? So the formula for that will be 1/2 multiplied by quantity x sub n over 2 plus x sub n over 2 plus 1. Okay? So, balik taan nga itong example nga 6. That will be 1/2 x sub 6 over 2 plus x sub 6 over 2 plus 1. So, this will be 1/2 x sub 3 plus, mahimo man ng 3 plus 1. So, x sub 4. Okay? So, meaning, i-plus na nimong duha and then divided by 2. that will be the average of your values. Okay. Okay, let's have this example. Katotong first example nga table. N is equal to 13. Ato lang tayo ang class. What's the difference between getting the mean, no, with one value that has with one observation nga extreme kayo versus getting the median nga naa kay isa ka value nga extreme. So we'll have two sets of data. One is katong original na to. Second is katong naa kay extreme value. So if you arrange that from the smallest to largest, mo na yang itsura. Okay, so take note mo itong extreme value no for the second set of data. So if you get the middle value class, since n is equal to 13, that's an odd number. So it's very easy to get the median, that is just x sub 13 plus 1 over 2. That is x sub 7. So maglihap lang tayo. 1, 2, 3, 4, 5, 6, 7. So for the first set of data, 2.82. For the second set of data, 2.82 lang gihapon. So nakita nato nga even though naata extreme values sa second set of data, the median is still the same for both sets of data. So dili kay siya affected sa imuhang extreme nga value. Okay? Okay, what if n is odd? So 8. Okay, so again, we rank observations from smallest to largest. This is another set of data with, again, an extreme value of 41. So we get the median, that is the average of the middlemost values. So that is 1/2 multiplied by x sub n over 2, kanisha 8 over 2. So that is x sub 4 plus x sub 5. Okay, so ihapon na po nimo 1, 2, 3, 4. Okay, and then 5. So kanang duha imong paan og average. So the median of this set of data is 8.55. Okay, let's go to mode. So ang mode class different from getting your median and mean, no? Because all you have to do here is you just observe you just count unsang observation ang ga-occur most frequently. Okay, so this can be used as a summary measure for all types of data, actually. So dili lang ordinal, dili discrete, o ilang continuous. So all types of data. We have different graphs, no, for the different values of your mode. We have unimodal, isa ra ka mode. We have bimodal, duha ka mode values. Positive skewness, kung imong mode again is nasa left sa imong mean somewhere, dire man imong mean, if you can recall sa itong first nga slide. And then nadire imong mean, so nadire imong mode, nasa right side sa imong mean, that will have an effect nga negative skewness. Okay. So sa'yo na kay klase imong buhaton for getting the mode, no? So if you have a data set here, for example, 3, 3, 6, 9, 15, 15, 15, so on. Okay. So all you have to do is identify which observation occurs most frequently than the other. So in this case, 3 occurs twice. Buta na itong 2 dira na. 6 kay 1 once, 9 kay once, 15 thrice, 27 twice, 37 once, 48 once. So the number of the observation that occurs most frequently is 15. So that means 15 is the mode of this data set. Okay. How about the second data set? 4 occurs thrice, 9 occurs once, 15 occurs thrice, 27 once, 37 once, and 48 once. So the 4 class and the 15, both of these observations occur thrice, no, thrice times the others, or more frequently than the others, and they have equal frequency. So in this case, you can say that 4 and 15 are modes of the set. So basically, dili din necessary isa lang yung mode, pwede duha. Okay, pwede more than one. Pwede sad, number 3, pwede sad nga wala kay modes yung data set. Nga naman, in this example, all the observations occur only once. Now question, what if all the observations occur twice? Well, no mode yapon kana, because ang rule sa mode is that imong observation must occur more number of times. Okay, in that case, same man sila. Kung same sila once ga-occur, or same sila twice, same sila thrice, tanan equal, then wala kayo makonclude nga mode sa imong dataset. Alright, that's for the mode, mean, median, and mode. Okay, let's go to the measures of dispersion. So basically, as I mentioned, the measures of dispersion describe the variability in a set of the data. So how varied ang imong data. How are they alike? How are they different from each other? Okay. So this measure is a non-negative real number, meaning positive number and zero. Okay, mo man imong non-negative. Because it's important to notice, because it could be that your dispersion is zero. Diyan pasabot. Zero if all the data are the same, meaning they're not different from each other. So the variability is zero. And then it will increase class as the data become more diverse. If the data are very, very different from each other, kanang layo kayo siya from each other, then you can say that the variability is high. Okay, so the number or the measure ana will be a positive number, okay, greater than zero. Okay, let's go to the range. So na-discuss na ko ni when we get the width, no? When we measure the width of the intervals that we're going to make. So basically the range is the difference between your largest observation and the smallest, okay? And mura siya mean class in the sense that it is highly sensitive to exceptionally large or small values. Ibalik ta sa atong first example, kani ba? So ang range na to ani class atong first of data will be 4.05 minus 2.15. And that is just, let me compute that, wala na ba answer. That is 1.9 ang range niya. Okay, sa second data na to class is 40.2 minus 2.15. So that will be 38.05. Okay, so tanawa unsa kada ko ang difference. So it's just like the mean class because it's very sensitive to exceptionally large or small values. Example, kung small po kayo to, dako po kayo og difference gyapon. Dako gyapon kay kag range. Okay, so kana naman ang pag-solve sa range, let's go to last topic ni variance and standard deviation. So giusa lang ako sila because they're really related to each other. Basically, the variance is S squared. Ang S ni mo muna yung standard deviation. So, variance quantifies the amount of variability or spread around the mean of the measurements. Actually, both of your variance and standard deviation quantifies the amount of variability. Pero ang variance na ni mo naka-square siya, class. Okay, so this is the formula of your variance. This is 1 over n minus 1. Okay, multiplied by the summation of your x sub I minus x. So, nga naka-square class, no? So, kanay siya class, let's understand or let's have a more, siguro conceptual na understanding sa formula. So, when you have x sub I minus x bar or mean, this is your mean, di ba? So, we want to get the difference or the deviation unsa kalayo ang imong observation dito sa imong mean. Okay? That's how different, that's unsa tawag na, unsa unsa siya ka layo or unsa siya ni deviate from your mean. Okay, kani nga expression. And then you square that, and then you sum all of that, and then divided by n minus 1. That will be that, think of it as the variance is getting the average of the squared deviation. Okay, for the standard deviation class, all you have to do is get the square root of the variance, basically, okay? The positive square root of the variance. Okay, so same lang yapon, we just get the square root of the value of your variance. Okay, suppose we have this table. Suppose we have this table, class. Same lang yapon sa to ang first nung example. Itong original na to nga values. So first we get x sub I minus x, meaning this is the difference sa imuhang observation dito sa imuhang mean. Dito sa imuhang mean. Okay, unsa kita tong mean atong isulat-an dire. 2.95. Okay. So atong mean is 2.95. 2.95. Okay. So 2.95 padulong sa 2.3, that is negative 0.67. And okay lang na siya, class, nga nag-negative, dira ang uban nag-positive because square naman gyapon na nato. Basically, ato lang kita na unsa kalayo ang imuhang observation dito sa mean. So these are the values, no? Okay? And then you square that, mo imong values, positive man na tanan. And then you total that, basically, mo na ni siya imuhang total kani. Kana. Okay? Divided by katong n minus 1. So, divided by 12. So, your variance is 0.39 square liters. Okay? So, your standard deviation is katulang yung positive root ani sa imong variance. So, that is 0.62 liters. So, in a way, class, pwede ka makakonclude nga since your standard deviation is relatively small, that means it is not that far no from your mean imong mga values of observation. Okay, so standard deviation versus your variance. Ang standard deviation mo is used more frequently than the variance because it has same units of measurement as the mean rather than squared units. So both of these values, class, can be used again for measuring your variability, no? Pero sa duha, class, ang standard deviation mo is used more frequently. So kung mag-compare tag two groups of data, ang group with smaller standard deviation, as I mentioned before, has the more homogeneous observation. So meaning they're more alike now than they're different. Kay gamay ra man imong deviation. Gamay ra imong deviation from each other. Okay? Or from the mean. So the group with the larger standard deviation exhibits a greater amount of variability. So meaning kung mas taas siya standard deviation, mas ga-deviate siya from the mean or from the values itself. Okay? Wait lang, class, bago na yun po. Hello?
Hello, good afternoon, ma'am.
Yes?
Ma'am, galing, pwede ko mag-ask sa inyong number under inyong department?
Unsa ta, sir?
Kasi, sa org ninyo na under yung department, ma'am.
Org?
Oo.
ISEP. Ay, unsay org? Ay, sa school? JICEP.
Sabay sa mga sa students pa.
Oo, JICEP.
J-I,
JIECEP.
J-I-E-C-E-T.
Oh,
Sa ME, kabalo ka sa ME?
kalimot ko sa ilang name.
Sige, bye.
Bye-bye.
Thank you.
Yes. Okay, let's continue. Let's have an example, class. So last na lang dyan yun. Sorry for the interruption. Suppose we have this data. This is a data from my master's degree nga thesis. So basically what I did is I measured the change of the center of pressure sa sa akong mga subjects class, no? Ang mga participants, kung ga-sit sila gastan ang gawok. So, ang center of pressure this is where the point sa imuhang foot dito ga concentrate ang majority sa weight nimo. So, if na tiil dira class, ana lang na pa. Okay. Kung gatindog ka, somewhere diri man nagatipok. I'm not sure sa exact point. Somewhere dira gatipok ang center of pressure sa imuhang I mean, ang weight nimo ba, dira ga concentrate ang most of your weight, okay? So kung gasit ka o gastan ka, gamay ra kay siyang changes. Actually, when you summarize your data, when you summarize your observations, pwede naman siya i-write in this way. That is mean plus minus your standard deviation. That's how you present the data. Okay, so ang mean ani class 0.14 for sitting, standing is 0.07, meaning sa change of COPDI for sitting and standing, gamay ra kayo, meaning wala kay siya ga-change, kaya wala mo kay kagdaliho. Pero when you're walking, ang akong nakuha nga data there is 2.47, meaning dako kayo siya og change sa iyang center of pressure. Nga naman, kay dili naman ka dira kung maglakaw ka, mag-change ang point sa imong COP. Paglakaw nimo class, usahay na siya dira, labi na kung mura kag mualsa na ni imong heel nga part sa imong tiil. Okay? And then, ang imuhang trajectory sa imong COP ana class will be like this. Okay? So, gaya ka change ang point na kung asa ka concentrate ang majority sa imong weight. So ang mean ani will be larger. Okay? And then the standard deviation is like this. Okay? So this is how different or how apart your observations are. Okay? So labi na kung mag-thesis na mo, nya daghan kay mong data, that's how you present your data. You calculate the mean plus minus your standard deviation. Anong plus minus man na kay kung naa kay mean diha class. Meaning ang imong data is kumura na ba na siyang tolerance sa imong resistor plus minus 10%. So na kay plus SD dira dayon sa left side po nimo minusan nimo og standard deviation. So meaning kana di ang range sa imong values na along na data values. Okay, so that's all for the variance and standard deviation. Actually, that's all for our lesson for today. So prepare for quiz at sa atong next meeting face-to-face. So that will be the entire discussion so far for the midterm. Yeah. So expect for a solving and saman, mga concept questions. Okay, that's all and thank you for listening.